I just wanted to go over a couple of problems because some of you were still struggling or some of you were absent. So if we have y equals the natural log of x, let's remember the rule is to find the derivative. Right, x is my input, and so natural log of x is just 1 over x. But remember, if this is more than just an x, if we have natural log of something more than just x, then we need to use chain rule. Take the derivative of the inside, whatever that is, times 1 over whatever that inside is. So for example, here I have natural log of x squared. So notice my input is more than just x. When it's more than just x, I need chain rule. So to take the derivative, I take the derivative of the inside. So that's x squared, we get 2x, times natural log of something is 1 over whatever that input is. And so final answer, 2x over x squared, which is just 2 over x. We can reduce. So if we look at, let's say, something like this one. So this is written, so we have, let's see, look how this is written. They wrote this sort of like a trig function. So let's just rewrite that. This is x times ln of x cubed. And so always think about what strategy are you going to use. So notice I have something, I have x times something else, another function here. So it's going to be a product. So the derivative of x is just 1. And here I have something being raised to the third power. This something is more than just an x. So I need to use chain rule. Derivative of the inside times derivative of the whole thing. So derivative of the inside, ln of x, is 1 over x times something being cubed is cube of whatever that inside is, squared. Power rule. 3 in front, 3 minus 1 is 2. And now I still have it as a product, so let's multiply on the diagonal. So x times this whole thing, well, x times 1 over x is just 1. And so I'm left with 3 ln of x squared. And now this side, so it's plus. So plus 1 times this guy is just this guy cubed. And I cannot combine them. They are not like terms, so that is the final answer. And just looking at some of these, right here, how many layers is this? I have ln of cosine of x squared. Well, this is not just cosine of x, it's cosine of something more than x. So here is my inner, and then cosine, and then natural log. So there's 3 here. If I look at this guy, I have ln of something times ln of something. So this would be a product. So let's do one more of these. I'll do, okay, why not? We'll do this one. So here I have 2/5 ln, and here's my input. Again, there's something going on here. It's more than just an x. So I have chain rule. This 2/5, well, it's just a constant being multiplied to my function. So whatever my derivative is, I just multiply it by 2/5. So y prime equals, I have 2/5 times natural log of something, well, derivative of the inside, I get -4, times the outside. ln of something is 1 over that something. 1 over that. So let's clean that up. I have a fraction bar. This is all being multiplied. So in my numerator, I have 2 times -4, which is -8. And in my denominator, I have 5 times all of this. So 5 times -4 is 20x plus 5 times 1 is 5. Now just to go over exponentials. So let's remember our formulas. If I have y equals e to the x, well then y prime equals, right, we say e to the x is just e to the x, but formally here's my input. So e to the x, if I took the derivative of the inside, that would just be 1, and then e to the x is e to the x, well there's my 1, times ln of e, right? Derivative of x is 1. Derivative of e to the x is e to the x ln of e. But these are just 1, and that's why it's just e to the x. Which is why if I have exponentials, if I have b to the x, where b is some constant, y prime equals, again, derivative of my inside is just 1, so I don't care about that if it's just x. But b to the x is b to the x, natural log of b, the base. So for example, with this one, here I have 16 raised to something. It's more than just x. Therefore, I need chain rule. So I know, according to my formula here, b to the x, ln of b, and then times the derivative of whatever that inside is. So I have 16 sine x times ln of 16, right, is my base, ln of my base, times the derivative of my inside. Sine of x is cosine of x. Final answer. Cannot multiply these guys, can't combine them together, they're just being multiplied. You can't combine them. Just to reiterate, number 7, e to the 7, that's just a constant. E is a number. So the derivative of any constant is always just 0. If I do this one, I showed you the answer key using the product rule, right? I could bring this up into the numerator as x to the negative 1 and use the product rule, but let's do the quotient rule. So by quotient rule, I have low times derivative of high, e to the x squared, that's more than just x. So derivative of my inside is 2x times derivative of the outside is e to my input. So low d high minus high times d low, derivative of x, just 1, all over low, denominator squared. So let's clean this up. We have f prime equals x times 2x, I get 2x squared, e to the x squared minus e to the x squared times 1 is just itself. So you can leave it like that, or we can make it look even nicer. Since both of these terms have an e to the x, e to the x squared, we can factor it out. I have 2x squared minus 1 all over x squared. Final answer. Hope this helped.